energy, right? You know that energy is very strongly related to almost every aspects of human, social, economic development. So the link between energy and wealth is very much well established. The need for energy to improve the livelihood is very well established. And also the link between energy and health is very much, because in order to provide health facility, in order to run the health facilities, energy is very, very fundamental. And energy, of course, very much also linked to the nutrition, because energy directly and indirectly, energy and water is a very important area. As you know, water and energy both has very strong bidirectional link. Water is very important for energy, and also energy is very much related to the water. And also we have been talking about energy, water, food nexus, and how to optimize that. So they are very much well-linked topic. And also energy is very important for shelter, because when you say shelter, that means a lot of construction material, a lot of buildings, and the energy is very, very fundamental inputs to all those processes and the materials. And of course, for infrastructure, transport, education. So energy is very much linked with all different areas. Okay, they are also strongly and significantly related to the consumption of energy. So that means all these, health, nutrition, water, development, economic growth, GDP, they are very, very strongly linked with energy consumption also. I'll show you some of the relationships there. Okay, now if you look at this figure, yeah, by the way, you have all the slides in Google Drive if you want to look at. If you look at the relationship between per capita energy consumption, and per capita GDP, you see here a very clear link that energy and economic growth is very much well linked. And of course, the different countries have operated differently. This looks like a spaghetti chart where, here the data is little old, but somehow I like this formulation of the picture. That's why I use this picture. Here, actually, you can see how every country have moved over time from 1980 to 2003. Looks like a spaghetti, spaghetti kind of one. But the general outcome is that per capita energy consumption and the per capita GDP is very, very closely linked, very linked. That means for economy with the higher income, they need lots of energy. Or you can also say conversely that energy is needed for growth. But of course, how much is needed, in what way it should, or whether we can dampen that those are something that need further consideration. Now, also, if you look at this particular figure, which is a bit more recent figure, you see that here the figure is plotted from 1990 to 2019. Here also you see that different regions of the world have different relationship between per capita GDP and per capita energy consumption. As you can see here, especially North America. North America has a very high energy consumption. Here in the figures, I don't know why they wrote energy efficiency, then that should be energy consumption. So high energy consumption, but also high GDP. And if you look at the color in the kind of red and the dark blue, then you see that Asia Pacific and also South and Central America. As you can see that they are in little lower end of Africa also, but now they are also slowly moving upwards. So what I'm trying to say here is that there is a clear relationship between the income and the energy consumption. So energy is a very strong input to the economic growth, and which also means that higher economic growth needs energy. But at different stages, how to optimally use energy is still a question. Now, this figure also, somehow I like this figure because it shows very clear that certain regions economically are different. But also, if you look at Europe in particular in this figure, the one with the orange dots, you see that in case of Europe, is actually a little bit going back. The curve is, US and North America and Europe, curve is going back also a little bit. So, for example, there is lots of decoupling also happening in some part of the world. Now, also, if you really see the relationship between energy intensity, which is energy consumption per unit GDP and GDP, here, just if you look at figure, don't worry about scales. I was trying to figure out how the scale has been scaled, but I like this figure very much. But the figure is correct in meaning. So what it shows is that in the countries with higher GDP per capita, they tend to be more efficient in terms of economy, energy application economy, right? So energy intensity is declining at higher GDP per capita, right? So that means the countries whose income is high or which are at a higher level of economic growth has been able to use energy more optimally to produce GDP than the countries who are at the lower end. So this shows the efficiency of the economy with respect to the energy consumption, right? So this figure here is for all countries or different countries, 137 countries for 1990 to 2014. And of course, this is not an unknown fact. We know that energy intensity has been reducing over the time. But sometimes we see reverse, but hardly we see reverse. Sometimes we see reverse, but generally we are improving in terms of energy intensity. But this at least shows us some kind of clear relationship. Now, also, energy is very important because energy influences lots of things. This figure I picked up from the World Energy Outlook 2022 from International Energy Agency. Here, you can see that the energy is very important part for the inflation. Whether it is food, for example, due to the Ukraine-Russia war, when there is an energy crisis, then that energy crisis means the energy becomes expensive. Then that affects lots of other sectors, including food sector and many other service delivery sector. And there is an inflation happens because the energy is a very, very strong input. Here, you see how has been the relationship between energy inflation and the food inflation. And interestingly, what you see is that in the low-income country, that relationship is more stronger, right? For example, particularly, these green dots here. These green dots are low-income countries where the rise in energy consumption and the energy price would tend to increase food price more steeply than compared to other regions. But energy is very, very central. That's why energy is very much linked with the poverty, livelihood, many other things, not only in the rural area, but also urban area and country as a whole. Now, of course, a lot of analysis has been done, linking energy not only with the one particular parameter such as income, but human development index as a whole. I don't know how many of you know that UNDP produced this, human development index and human development report. Now, human development index try to look at development in wider context, not only based on GDP, because GDP has been used as a goal but the Human Development Index, SDI, brings other elements, education, and many other elements into that numerical figure, and they publish this Human Development Index. I have a next slide. I want to show you what Human Development Index means. But here you can very clearly see that energy is energy and the Human Development Index are very much closely linked, and especially in the earlier, relatively earlier stage, they have a very strong correlation. If you look at, let's say, up to 50 or the 60 gigajoule per year per person in this figure, then you can see that it's almost straight line kind of relationships. So that means as country would improve their Human Development Index, the energy sector's role is very, very important. But of course, after achieving a certain energy per capita, then maybe it doesn't add too much into the SDI. But at the early stage of the development, energy is very much needed, right? So this kind of relationship for what we see in this figure. Now, what is SDI? I just mentioned to you that for a long time, our policymakers just focused on GDP. Now, what is GDP? GDP just measures the monetary value of all the goods and services, all final goods and services produced within a territory of a country in a given year, right? So now GDP only counts how much final goods are produced. Basically, it shows the value addition and the total production. But of course, it doesn't capture lots of things which doesn't come into the market. It doesn't capture a lot of things which are hidden in the system. It doesn't capture informal economy. It doesn't capture, how the economy from underground economy, informal economy, economy because of the corruption. There are lots of other things which GDP doesn't capture, but still GDP is a good indicator. Sometimes we overuse it, sometimes without understanding. But now this SDI, what SDI try to do is to look at GDP, but also try to add some other elements, especially health aspect. And one important indicator added there is a life expectancy at birth, and putting some education also together. So particularly the literacy rate and the combined gross enrollment ratio in the school. So I think, you can see the formula here. There is some benchmark, minimum value, maximum value. So at the end, SDI incorporates not only GDP per capita, but health and education, and income, these three. Now that SDI has been, appreciated, that at least we are making effort to go beyond GDP as the indicator for development. Of course, development and economic development are two different things, right? At least SDI try to help us think about development, bigger context than only the human development, than only the economic development. So now of course, the one point that I want to highlight is also that since we are talking about energy sustainability here, this SDG 7, which talks about energy with few targets we discussed the other day also, is linked very closely with many other SDGs. Now, with this paper here, try to map out that particular relationship together with a few theoretical foundations there. For example, whether the energy goal is indivisible with certain goals, they are reinforcing positively to other goals, whether they are enabling other goals, or actually energy goals are actually creating problem, constraining, or counteracting or even canceling the other goals. So how is the relationship between these different SDGs with respect to SDG 7, right? So in generally, you can see that the second figure with the red color, these are the situations where energy goal has implications, right? Negative implications to other goals. But as you can see here, in many of the goals, actually, in summary, we can say that there is a positive interactions. The positive interactions between SDGs with respect to energy actually outweigh the negative one. Of course, this interaction synergy trade-off between goals that could be different in different contexts, but at least what we see is that positive interactions outweigh the negative interactions by putting in this figure goal number 7 in the center, how goal number 7 works with other goals. So what I'm trying to say here is that energy goal is fundamental, and if we could not provide affordable and sustainable energy, then to meet SDG goals of energy, then actually it will be difficult to meet other goals also, right? So that is a message basically coming out from this figure. Now let me now a little bit go into the bit of a nitty-gritty. What do we mean by energy, right? Why do we need energy? You know, it's the fundamental question. Energy is not something we can eat. No, actually we can eat energy, right? Whatever we eat is energy, right? All the food we eat, everything we do is a calorie. But in energy sense, often we say that the energy demand is derived demand. That means we cannot eat energy, but we need heating, we need cooling, we need cooking, we need motive power, we need lighting. So we actually need the services, and the energy is what help us provide the services, right? So for example, we need lighting. Now we can design a building with sky lighting so that we don't need energy. That is also possible, right? Because our demand is lighting, right? Our demand is not electricity. Our demand is not a LED light or the compact fluorescent lamp or the fluorescent lamp. Our demand is fundamentally lighting. Now energy is the one which provides that lighting, right? So that understanding is very important. So we call it energy as a derived demand. Then of course, then we consume energy in order to provide service to us, to fulfill our needs. Now that energy which fulfill the need, there could be a lot of things can happen. We can bring that energy more efficiently. We can use efficient devices so that less energy is needed. We can improve transmission distribution of these energy carriers, fuels, so that leakage is less. Or if you go all the way upstream to the primary energy supply from your final energy consumption side, you see that there's lots of losses in the system. There are lots of energy transformation happens, refineries, power plant, all these things, there's a lot of losses. Then if you look really at the primary energy supply side, we need a huge amount of energy. Just simple, we call it 1 unit of energy saved is actually much bigger amount of the coal or oil saved if you really go to the primary energy side, right? So, but okay, this figure shows you global energy use. And we in 2019, I picked it up from our IPCC AR6 working group third reports, energy chapter, that is chapter 6. The primary energy supply is around 585 exajoule, and the final energy consumption is around is around 448 exajoule. And if you see the difference, why between difference, these are efficiency, right? So these are basically efficiency of supply from primary to the fuel consumption side. Then if you see oil, Oil is extracted, it goes to refinery, then it goes to many different functions. For example, oil here, it is a dark blue color after refinery, becomes oil products, and the big chunk of that goes to the transport sector. As you can see here, the big line from the green is actually going to the transport sector. But of course, big chunk also go to the non-energy use, lubricants, so lubricants and so many other applications. Now, if you look at the coal and natural gas, you can see that the coal is used in power plants. If you see that red color, from coal and natural gas, big chunk is going to this, electricity, red color. And that, of course, electricity goes to industry, residential, commercial, and a very small fraction to the transport sector, because still the electricity consumption in transport sector is still very, very small. Then the natural gas also, some natural gas directly used in industry, and the big chunk of natural gas go to the power sector, go to the, and then produce electricity. Coal also, big chunk of coal is directly used in industry, but of course the coal used in household and residential sector is very, very small. Also, you can see through this that hydro, for example, hydro power goes to the electricity sector. Nuclear also go to electricity sector. Wind, solar, solar thermal also possible, but still the solar thermal is small. But solar electricity, wind electricity now is increasing rapidly, and geothermal can be used in two different ways mostly. Either produce electricity from geothermal or using geothermal to heating purpose in particularly residential and other commercial applications, geothermal. And biomass is one area. It can go to many different, for example, biomass can go to electricity to produce electricity. Biomass can be directly used in industry, and the big chunk of biomass is used as a fuel for burning in residential and commercial sector. And also now from biomass, we can make biofuel, and the biofuel sector and that biofuel are also increasingly used in transport sector. That's why you see that a small amount, around 4 exajoule from biomass going to the transport sector. That is basically, this is basically biofuel going to the transport sector. And some natural gas is used by the transport sector, natural gas vehicles. So we use our demand of energy is in industry, residential and commercial sector, for non-energy application like a naphtha or the lubricants, so many other things, or transport. But in order to meet the energy demand in these sectors, different energy carriers provide us that service through the entire chain, through the transformation and the refineries sector, and then we have primary implications. So what I'm trying to say here is that in this global energy use, there are a few things to be noted. For example, if you look at everything on your right, industry, residential, we and transport, if we could reduce energy demand there, then we save a huge amount of resources on the primary energy supply side, right? But still, we can't make our demand zero. We still need energy demand. Now, if that energy demand on your right can be produced by the sustainable energy solutions on your left, then that is a good thing. For example, if we use oil and coal, you have a lot of air pollution, you have a lot of greenhouse gas emission. But if we could switch that to hydro, wind, solar, and others, then we solve lots of problems. Because oil and coal, if we avoid, then we'll reduce the pollution, we'll reduce other things, and also we might be improving energy security, because unlike oil and coal, solar, for example, is widely available in many parts of the world, right? So that might also help you to boost your energy security. And also the efficiency is very important here. Let me mention, typically the power plant's efficiency is somewhere between 30 to 40%, depending on what kind of, for example, if it is combined cycle, advanced natural gas higher power plant, then its efficiency is high. But if it is traditional coal-fired power plants, then the efficiency even maybe less than 30%. So what I'm trying to say here is that the efficiency is very important here. Reducing demand is very important here because that reduces the pressure upstream, and switching to the sustainable energy is very important because if we could switch from oil and coal and natural gas to hydro, nuclear, wind, solar, then that is a big energy transition we are talking about. Of course, that is what we talk in the context of energy transition, because this energy system is linked with so many problems. Our human civilization after industrial revolution, we have done a lot of harm to the atmosphere, to pollution, our health, because the industrial revolution was very much based on fossil fuel, coal and oil. Then after that, oil becomes cheap. Then now natural gas. So we have to move away from this fossil fuel energy. So that really brings us a number of issues which we have to deal with in sustainable energy concept. Nuclear energy is a very complex energy in a sense that there is a lot of debate around nuclear, and a lot of people don't want to count nuclear in a sustainable energy discussion, saying that the nuclear we have to avoid, we have to reduce as much as possible because it's a very dangerous energy. And the nuclear accidents have shown us time and again that we have to be very, very cautious with nuclear. But definitely nuclear, we like or don't like, nuclear is a cleaner energy source. And we do have lots of radioactive materials available around. But yes, nuclear is something highly debated subject. And usually in our sustainable energy discussion, usually we try to avoid nuclear, in this transition. But if we can harness safely nuclear energy from technological perspective, nothing wrong. But of course, society and other perspective, nuclear is a very, very difficult source of energy. Cost and technology of the solar has improved a lot. Now the solar can be competitive, and in some cases, solar can be even cheaper than our conventional electricity. But you rightly said that since solar is an intermittent source, we cannot fully rely on solar, right? Fully rely on solar. That's why fully relying on solar is difficult. It can have applications, but it needs a backup. And also now one very important area we have been talking about is storage. Now the storage technology is improving. The price of storage technology is going down. And now utility scale, battery or the other kind of storage they are working on. But there's a lot of projection that the battery and the storage technology price will go down in the future. So that's why the question of solar at the moment is to integrate more and more solar into the system as much as possible. But standalone solar system without backup is still a problem. So that's why solar has to be dealt cautiously, right? But some other sources are nice. For example, hydro, right? Hydro can provide best energy, but of course, hydro also can be seasonal, because in the hydro there is a lot of variations between, there's a lot of seasonal variation in hydro, right? So at what level we design is something important to consider for hydro. But the wind, so basically we have to have an integrated energy solution, and we cannot depend only on one solution, right? Something that we have to work out with. I can tell you, I'm a very good person to talk about nuclear, because when there was a Fukushima nuclear accident in Japan, I was living in a place which was 175 kilometers from Fukushima nuclear accident. Then I have felt myself how it feels to be in the periphery of nuclear accidents. Of course, there is one worry for aftershock from earthquake. Then the second worry was everything was contaminated. We struggled to find the water. We worried about what to do. We worry about what happens to the children, even though we thought, okay, we are old, maybe something happens. It will take many years, but what happens to children? When I was in Japan, there's a water was very scarce to get because the bottled water was run out from the shelf, and tap water has a higher concentration of the iodine isotope from the nuclear power plant. Then even we collected water, and half-life of isotope iodine is very great. So we put in the bucket, left for 3-4 days. Half-life, then use the water. We have gone through that. So although health impact of nuclear is very different to understand, still we realize that health impact is still quite unknown. High exposure of radioactivity for a short time and the low dose exposure for a long time. So what are the different health implications? Still is not very clear. And if maybe that there's a big accidents in Chernobyl in former Soviet Union, and also Nagasaki and Hiroshima, nuclear bomb. Most of the knowledge from that is still in the domain of the the sectors that we don't know. We know that there's a lot of studies done on the survived people from Hiroshima, Nagasaki, but still many of those research still may not be in public domain. But it's very scary. So that's why I fully understand what Sujesh mentioned, that nuclear thing is quite scary. We have enough uranium around. If not uranium, we have a lot of plutonium around. So my one sense, I have to look at the reserve and the resources for uranium. Yes, these are also limited, but I think we still have plenty of radioactive material. Perhaps there are some estimates available. At least those of you in Nepal perhaps know that there is a lot of speculation that Nepal also has a lot of uranium reserves, which Nepal have not been able to tap at. Especially towards the northern part of Nepal, lots of uranium mines are there. So I think, but my one perception is that we have enough radioactive materials for the time being. From the natural resource perspective, definitely we have to be careful, because we have to conserve our resources and not to deplete. But what I was saying is that there should be in my, I have to go and look, but my perception is that we have enough radioactive material around. And also one of the, I think just now Prajal was typing something, the issue about the overuse of nuclear is also the scare for the nuclear weapons program, because the type of material you need for nuclear power plants and for the nuclear weapons is similar. Of course, for nuclear weapons, you need highly enriched uranium or the plutonium, and that technology is no longer seems to be a rocket science. It's only a question of not doing. There seems to be enough knowledge exists if we allow country to do it. So I think the proliferation of nuclear weapons, the controlling, even from that perspective, going nuclear and encouraging more nuclear is precarious. So even from that weaponization perspective, nuclear should not go. So but now how to use that more better way is a problem. So that's why my thinking at this point is that we have to have complementary multi-source energy system. We really cannot depend only on one. And of course, some country like Nepal, Nepal is a hydro-based country. We have enough hydropower to power us if we could harness all. Then, for example, we have enough solar. Wind could be limited, but the combination of the solar and hydro should be enough for Nepal. Country like Bhutan, enough. But some other country, not enough. For example, India. Of course, India depends hugely on the coal-fired power plants. But a lot of things can be complemented from Nepal and let's say Bhutan, and also India is massively working in a solar, but of course solar is again intermittent source. So combination of solar, wind, some nuclear, some other forms, geothermal, biomass, and also in the future technology is evolving. Although we don't want to rely on carbon capture and storage. If we could develop that technology quite rationally and in a cost-effective way, there could be still some role for carbon capture and storage uh, in that context. So I think that those basically are issues that anyway we have to deal with, and we shouldn't focus only on production side. There are a lot of things can be done to improve the technology from the efficiency side, and also lots of things can be done in order to reduce the energy demand and making energy, and also moving away ourselves from energy intensive lifestyle and energy intensive production processes. So there's a lot more to do. So the sustainable energy transition should not look only from the perspective of the production side, but also from the wider and the much more comprehensive side. Okay, let me move on. Please feel free. Now, that's why this is my perception that the key policy question for us who work on the energy policy issue is how to provide affordable energy services to all without serious implications to local, regional, and global environment, and without depleting unsubstitutable natural resource now and in the future. So this, in this statement, there are lots of things, right? So this is a main policy question for us, and we have to find a way to, optimal system that suits our need, and this is often I find is the most important for us to consider. You know very well that energy systems are the major source for environmental pollution and also depleting natural resources. So energy systems have to particularly worry about environment because they have been the driving force for different environmental consequences at local, regional, or global scale. When you say about global environment, greenhouse gas emissions from energy is the major sector, major point. And then also energy is very much linked with the regional environmental issues such as acid rain, which is from the sulfur dioxide emission, especially from the high sulfurous fuel like coal. Now, even there are a lot of black carbon, brown cloud issue. Black carbon, also one major thing comes from the diesel and also from biomass burning, and that biomass also sometimes used as a energy. So biomass burning, diesel, these are a source for the black carbon, which ultimately cause brown cloud, and particularly in the Indo-Gangetic Plain, Nepal, India, that region. Maybe you have heard about atmospheric brown cloud, ABC. Issue is quite serious. Even there have been a lot of research now telling us that atmospheric brown cloud from the Indo-Gangetic Plain goes to the atmosphere. They were blown to the Himalaya, then they precipitate in the white snow, and it is changing the albedo, surface reflectivity of the snow, and that is also helping to fast melting of the glacier in addition to the warming. So there are lots of other black carbon link. Also sometimes soot also work as a cooling force for also. So anyway, energy is quite closely linked, and of course if it is nuclear energy, there are lots of links with the nuclear leaks. Coal-fired power plants and other power plants are sometimes very close to the ocean because the water is used to cool, particularly for the nuclear power plants. They need a lot of water. So that was also linked with a different kind of, soil, water, land, marine pollution. Then, as you know very well, that energy is a major component for local air pollution, motor vehicles, burning, boilers, use of, even this, oil, gas, all form of, mobile and stationary sources are linked to energy. And also energy is very much linked to the so-called urban heat island. I don't know how many of you know this term. We call it UHI, urban heat island. Usually the urban areas are few degrees warmer than the rural surroundings because of the lot of structural change, material change, vegetation change, water body change happen. So actually there are a lot of students in AIT have done PhD in urban heat island, including some of my students also. Even for Kathmandu, many of you who live in Kathmandu might have felt that Kathmandu is no longer like an old Kathmandu. And also the surroundings temperature is cooler than the Kathmandu, right? So this urban heat island phenomenon happens because of the lot of things, and one of the major factor is energy consumption and the heat discharge in the urban atmosphere. And of course, there are a lot of other things, waste to energy, and there are a lot of other links. So energy is very, very central to the entire gambit of environmental issue, from local to regional to the global. Now the acid rain problem has a little bit elevated because we were very, very actively globally in promoting FGDs, fluidized gas desulfurization unit. FGD had become now mandatory in most of the coal-fired power plants and the coal used in industries, which can scrub out sulfur from the before the flume goes out of the stack to the atmosphere. So FGD is a mandatory, and the acid rain was a serious problem. And US, China, Europe, they implemented very serious policies to control acid rain, sulfur dioxide. Actually, in US, one of the trading mechanism was started for sulfur dioxide control regime, and that's some kind of trading mechanism similar to carbon trading we do. Actually, the root of some of the carbon trading actually goes to our successful experience with the sulfur dioxide trading. And also in Europe, China, US, they had serious policy initiatives to control acid rain in the past. But now we have done pretty well on that front. Now, regarding key issues related to energy sustainability, there could be many issues, but I want to focus on few. One important issue is energy access. We have said that energy is very fundamental for economic development. Energy is very fundamental for human development. It's very fundamental for livelihood. It's very fundamental for lots of things about which we do. So improving energy access is also one of the major targets under SDG goal number 7, right? Energy access, particularly access to electricity and the clean energy access for cooking, right? These two are very much into the goal SDG 7. And second is energy security. I think I don't need to talk about perhaps energy security after what we saw in the war between Ukraine and Russia, right? So that war has led to the rise in oil and gas price, and energy security is anyway very, very fundamental for countries. And the other issue I also want to talk is energy subsidies. We have given so much subsidy in fossil fuel over the years that these subsidies are now problematic. These subsidies are providing perverse incentives to use fossil fuel and making renewable energy compete. That level playing field has been quite difficult because of the energy subsidies. And there are a lot of initiatives to remove energy subsidies, but as you can guess, energy is very linked with the inflation and so many other things. So if the subsidy is removed, there could be a lot of implication also. But we are moving towards the world to remove energy subsidy. But I'll show you an interesting slide that during the COVID crisis and during the Russia-Ukraine one has increased significantly because gas price went up, oil price went up, so there was need to provide some kind of comfort. So energy subsidy become worsened in 2022, 21, the recent years. And also, of course, I don't need to talk about energy, air pollution, and climate change link, especially for the decarbonization issue. We'll talk about that. And I'll only touch upon technology and costs. I want to show you that there are some promising technology like a solar, wind, many renewable technology. Technology has dramatically improved, and the price or the cost of technology has come down dramatically. If you look at life cycle cost, several folds the cost has come down. That's why solar is quite competitive. Although solar is an intermittent source of electricity, but it still is becoming quite competitive. Then also, we also want to get some sense of net zero energy system and the relevance of this discussion. So I'll try to touch upon some of the things in next in coming hour. In our current system, we have many subsidies inbuilt for fossil fuel, and unless we don't remove that subsidy from the fossil fuel, then it's very difficult for renewable energy to compete, because the social and the externality cost of this fossil fuel has not been taken into account, right? So my argument here is that we must remove subsidy from the fossil fuel so that sustainable energy or the renewable energy can play, so that we could create a level playing field for the renewable and sustainable energy sources. But of course, I'm mindful of the fact that removing energy subsidy, even for the fossil fuel, is a complicated subject, because that might affect the poor, that might affect the vulnerable section of the society. So subsidy is something, once we started giving subsidy, removing subsidy is very, very difficult. But now, of course, that doesn't mean that we can't give subsidy. We have given subsidy to solar, wind, so many other renewable energy in recent years. But at some point, these technologies should scale up to the level that they should compete in the market, and we cannot give subsidy all the time. But of course, we do need targeted subsidy sometimes. We call that as a targeted subsidy, not the blanket subsidies, but some vulnerable group, vulnerable section of the society, the subsidies should be targeted and not the blank check. But we can provide subsidy for some time, let's say for renewable energy technology, and once they scale up, there is something called learning curve. We know that if more and more implementation, the technology price comes down. So we need to support up to certain time, then they become competitive in the market, then the subsidy could be removed. So there are a lot of discussion about subsidy now, but I want to show you not on subsidy given or need to be given for renewable energy, but I just want to show you that how much subsidy we are giving at the moment to fossil fuel. And I want to argue that subsidy slowly we have to phase out, or we have to take out from the system. But of course, with due care to the poor and vulnerable and the disadvantaged section of society. Of course, solar price has come down, but still in many parts of the world is still expensive. And you yourself rightly said that we cannot fully depend on solar because it needs to couple with the storage and other systems. But we have seen impressive growth in the solar installations, and also the other one is moving very fast now is electric vehicles. Electric vehicles which also need a lot of electricity. But if we implement electric vehicles and the electricity system still comes from fossil fuel, then we are not doing good. But if the electric vehicles and then we use the renewable energy to provide electricity, then I think we can even replace the oil quite fast. And also, as Prajal was typing there, lobby from the fossil fuel industry is very strong. I mean, don't you think that our economy runs by the fossil fuel? There are powerful forces which don't want to lose the market, right? Which is quite obvious. And even for the battery technology, I always wonder why the battery technology did not improve dramatically. You'll be surprised that in 1900 up to 1910, there were more electric vehicles than the fossil fuel vehicles on the road. Between 1900 and 1910, there were more electric vehicles on the road than the fossil fuel, right? But now the motor vehicle technology progressed, oil becomes cheap, technology propelled, then the electric vehicles went into shadow. Battery technology could not develop fast enough to compete, and we were completely taken over by the automobile, and automobile running on the fossil fuel. Of course, this lobby is very strong. The fossil lobby, one of the richest companies, the most powerful companies are energy industries, right? Oil companies, coal mining, these are really, really forceful forces we have to deal with. Switching to new technology and also integrating more electricity to the grid, we also need to improve our grid infrastructure. So that integration element is very important. I'm not saying that we can do it. We must do it, no doubt. But that integration issue, seamless integration, and also technology adaptation, improving our infrastructure to cope with the new structure, that is something still very, very important for us, actually. Every country has certain strength. Let's say for Thailand also have a significant biofuel in energy system. Also, Thailand has a lot of prospects for the solar, and also Thailand had a lot of prospects for biomass, for example, right? So ultimately, diversity is very important, both for energy security and other things. Diversity is very important. Try to harness locally available renewable energy is very important, right? So there are lots of things energy policymakers have to think, but fundamentally, in order to scale up the renewable energy into the system, we have a lot of best practice technology, but we have to provide, we have to facilitate, we have to try to scale up that, and at the same time, we have to do many things. We have to go to multiple carriers, we have to go to multiple technologies, and at the same time, we have to reduce our energy demand also, improve efficiency. So ultimately, we have to do a lot of things, and there is no single solution, right? Ultimately. Okay, I want to show you our few slides, especially on state of access, state of energy access. As you can see in this figure, that your figure on your left shows you the global population without access to electricity by region. And if you see this figure, we have some reason to be happy that the number of population, global population without access to electricity has reduced significantly, right? From 2000 to all the way to 2021, we have been able to reduce that number quite steeply, this number. But also, if you look at the next set of dotted lines, now after the COVID pandemic, actually this global population without access to electricity has not only stalled, but the recent data shows that for the first time in last many decades, this number has increased. For the first time in many decades, global population without access to electricity has increased compared to the previous era. So there's a lot to do. Maybe it has to do with the price of energy, rising gas price and so many other things. And also on your figure on your right shows the global population without access to clean cooking. Clean cooking is still a problem, right? Clean cooking is a problem in two parts of the world. One is sub-Saharan Africa and other in South Asia, in principle. Of course, many things in other places, but basically it's in South Asia and sub-Saharan Africa, cooking. And for electrification, this big problem comes from sub-Saharan Africa. Asia has done much better in access to electricity in last few decades, but sub-Saharan Africa is a major problem for access to electricity, and South Asia and sub-Saharan Africa is a major problem for access to the clean cooking fuel, right? So as you can see that we have huge number, we have billions of people without access to clean cooking fuel. So that is one major area we still have to grapple with when we discuss with the access issue. And also, if you look at the next figure, I try to pull some this data from the very latest IEA report, International Energy Agency report from 2021. I told you earlier that the pandemic, inflation, and the energy crisis have set back the global progress on universal access to electricity. So for the first time, we had all this line going down. And in 2020 and 2021, we had 754 million people without access to electricity. Now that has increased to 775 for the first time in last many decades in 2020. Of course, it has to do with the energy price, inflation, and so many other things. Now, as I mentioned earlier, I already showed in the last figure, we have billions of people without access to the clean cooking fuel, and that has remained a big problem. And we still struggle for this clean cooking fuel. Of course, there are a lot of initiatives, improve cook stoves, other things. And also you will be surprised. Those of you coming from Nepal, please look at the recent data from the Nepal census. The access to clean cooking has improved in Nepal, but that improvement came from switching from biomass to LPG, which is not good because LPG creates more problem for Nepal for energy security and lots of other things. Rather than access to electricity and using electricity for cooking, or access to more modern, cleaner bioenergy or biofuel, people are switching from biomass to LPG. That sounds good, from the easy and better, but importing LPG creating more problem because LPG has to come from India. There is already a huge fiscal problem because of this energy issue. So sometimes this transition could look nice, but one has to be careful when dealing with such transition. Now, again, this was quite interesting, figure. I noticed this report sometimes back, and I could pull up the slide. This is a energy security problem, and which country relies how much in the Russian energy, because Russia-Ukraine war really was a problem, and the Europe depends so much on Russian energy, basically oil and gas, right? So this is a total Russian fossil fuel reliance of the country. Like, look at a country like Hungary. The scale is, this brown line is 100. This, brown line is 100. So a country like Hungary almost rely 50% of their, energy for the importing energy from Russia. Then also, if you look at the country like, Turkey, country like, Slovakia, Hungary, Bulgaria, even Poland, you can see that there's a huge reliance. Now this is something you have to deal with when you talk about energy security, right? This is just one example why the geopolitics is very, very, very important. There are smaller nations where the energy can be blocked for a geostrategic reasons, right? If one country didn't like other country or policy, they can play around with the energy and block energy, right? So lots of things are possible. So energy security is a serious problem, especially those of you coming from Nepal. I think energy security is a very important because of the landlocked nature of Nepal, and also for the fact that Nepal has a lot of hydroelectricity, and for the fact that the major trade and other dollar and other things goes for the particularly oil and gas. So energy security is a very, very important aspect, and that is a fundamental, even in Thailand, right? Even in Thailand, how to manage energy security, how to save the country from the oil shocks in the energy system, right? In Thailand, they have some system that they have some buffer. They always create some kind of a buffer. And that sometimes if the oil price is very high, they will release some more fund from that system. When oil price is low, the money goes back to the fund, so that they have some kind of management system in order to try to stabilize the price. Otherwise, energy security becomes very serious, not only from supply perspective, but overall countries perspective. Let me say a few words, then I think we'll go for a short break. Now, let me say a few words about subsidy. I mentioned to you that subsidy is a problem. This is the amount of the subsidy, fossil fuel subsidy, globally given by the countries. This is estimate from International Energy Agency, and they have a different estimate from International Monetary Fund, IMF, and many other sources. So now for the first time, if you see, compared to the 2020, fossil fuel subsidy has increased almost 4 to 5 times. Right? Of course, this is to help public against the rising oil price, right? Because due to war, due to pandemic, now the price of energy has gone up. So now the governments are compelled to give a subsidy for the fossil fuel. Now the fossil fuel subsidy increased almost 5 times in 2022 compared to 2020. It was declining, but due to the recent crisis, the fossil fuel subsidy went up. And one of the major difficulty for renewable energy was fossil fuel subsidy, right? That creates an unfair playing field for renewable energy. But now, due to energy price, energy inflation, governments have pumped more subsidy into the system, and hopefully that would not be the case in coming year. But at least this is the situation. And my last slide, maybe before we for a break, this is the value of the fossil fuel subsidy by the top countries. Russia, close to the $80 billion subsidy. Iran, China, India. In India, over 40, almost $50 billion subsidy. Fossil fuel subsidy in India. So this is a list of countries. The list of countries, and of course, the high fossil fuel prices definitely hits the poor the hardest. But we always say that subsidy need to be well targeted, but in reality, it doesn't work. Actually, in many subsidy are targeted, but the unwanted group of people take advantage of subsidy also. So that's why subsidy may not be necessarily a bad thing, but it's very, very difficult to handle, very, very difficult to manage. And the real benefit to derive from subsidy, one has to be very, very careful. But better to spend on the structural change. Sometimes even for a relief operation, we just pump money, but then we forget to do something structural change. For example, if there is volatile fuel prices, we do an immediate subsidy rather than putting long-term structural change into the place. And the crisis gone, we forget. So subsidy is still a problem. After this fossil fuel subsidy discussion, let me show one figure here. This one is the location of settlements with high concentration of PM10. Why this is important is that one of the major reasons why PM10 and pollution is from energy use. Of course, there's a big chunk of biomass burning and other things, but also energy is very, very important. So many of our cities are choked with the pollution, and the energy consumption is definitely directly, indirectly one of the major reason for this PM pollution. So even for managing this global PM problem, health crisis, we have to address the energy system. This is very, very important. Maybe the oil price increase, again, oil price goes down. Sometimes the oil price, even though goes down, countries don't bring oil price down. They will rather put some money, still to keep in the state buffer to really compensate. So lots of things they do, but generally, oil price is high. So also there is a lot of because we said earlier that inflation is very much linked with the oil price, because oil is a fundamental backbone for the whole distribution system and all. So if you don't provide, again, oil subsidy to the energy, then your all other sectors price goes up. So they have, I guess they have very complex balance to be made. Okay, let's talk about now decarbonization of energy system. Now, decarbonization, we all know about climate change, right? Now we are in the world that if you don't about climate change, digitalization, even like general talk doesn't end properly, right? So we have such a focus on climate change. Now, global climate change has already happened for about 1.1 degree. World is 1.1 degree warmer than it was pre-industrial times. Already 1.1 degree happened. And our goal, our goal is 1.5 degree climate stabilization, right? So we have already increased 1.1. The amount of space we have needed, we have is very, very limited. Yeah, Chawat, since I saw your question, what I said is that, China looks huge in terms of subsidy, but China has a 1.3 billion people. So looking at the scale of the economy and looking at the number of people, that number is high, but still, if we look at per person, maybe that subsidy might not be as big as it might look if we look from if we consider the population of China. So this is what I was trying to say. Now, if Professor Ed Hawkins, used this term called climate stripes. He created this something called climate stripes, which shows that the blue means your temperature is actually lower than the lower than the average of 1850 to 1900, and as you become more and more warmer, then the color palette change. So somehow I like this figure a lot. So what it says is that climate change already happened, and even the generation which were born in 1950, they are 70 years old now. They have already faced climate change. Now just imagine who were born in 1980, they become 70 years old in 2050, right? And 2050 is a place where we need to bring our carbon neutral. We have to make net zero emission, right? And those people who are born in 2020, now 3 years old, they will live in, let's say 70 years, they will become 2090. So what I'm trying to say that it's not very far. Sometimes we say, oh, climate change, it's very far issue. No, it's not far. This has already happened in our generation. And for the generation born in 1980 or now, it's not very far. Climate is already happening. And that feeling that climate change is a distant issue is no longer the case, which means that we need to act. Now, if you really look at the historical greenhouse gas emission, actually this comes from my chapter of IPCC. I was in charge for this figure and this chapter. So in 2019, we have 59 billion ton of CO2 equivalent greenhouse gas emission we emitted, right? And if you look at this number, we talk about climate change, we make a lot of noises since 1990. Look at the trend. We are increasing. Yes, the growth rate has little declined, because growth rate is here 1.3% in this decade. A previous decade, 2000 decade, it was 2.1%. Yes, growth rate has declined a little bit, but we are at the highest level of emission in the known history of the world, right? So we haven't been able to reduce our greenhouse gas emission. Now, if you look at where it comes from, of course, CO2 emission from fossil fuel is a major source. That's why the energy system is in hotspot, right? And of course, we have some from land use change, some methane, nitrous oxide, F gases, but basically it's coming from energy. And if you look at our transition of the CO2 emission from fossil fuel and industry, the bottom figure on your left, you see that this is increasing from 100 to, let's say, 160, 70% has already increased. And some gases, all those small F gases, fluorinated gases, increasing very steep, but of course, still their amount is still. So again, what I'm trying to say is that CO2 emission from fossil fuel and industry is a major source. That's why it matters to the energy. Now, if you look at, you can look at this kind of emission from number of perspectives, right? We can say, if you really look at the per capita, Australia is the worst country in the planet. If you look at per capita emission, right? In 2019, Australia's per capita emission is very high. Australia, Saudi Arabia, Canada, US, Russia, Korea, Iran, these are the countries with the highest per capita emission, right? But doesn't mean they are a relatively small country also. Now, if you look at the volume itself, the China in last decade, 2010 to 2019, the China, India, Indonesia, Vietnam, Iran, these are the countries which have contributed highest amount of CO2 emission. Of course, there are more people, let's not forget that, but in terms of volume. But if you look at the last few years, last one decade, but still countries like Vietnam, Indonesia, their growth rates of emissions is very high. Why Vietnam? Vietnam is a country, very dynamic country, economically rapidly growing country, and it demands lots of energy, right? Lots of energy. So energy is a kind of driving force. Now, if you really want to see the role of energy in this entire climate change discussion, you see that energy, the figure on your top bar, you see that around 33-34% of the global greenhouse gas emission, energy sector is responsible. Yeah, around 33, 34, with the decimal very close to 34 actually, around 32 to 33, 34% energy sector is responsible. But if you want to see sector, you can, because okay, electricity is used in building, electricity is used in industry, electricity is used in the transport sector. Now, if you try to allocate that to the different sectors, then you see that the building is responsible for 16%, transport responsible for 15%, and the Afolu sector 22%, and the industry 34%, and the energy sector directly without electricity and heat is responsible for 12%. But in this figure, all electricity, which is actually energy sector, is already embedded in industry, building, and other sectors. But we can say that energy sector is responsible for at least 33-34% of the global greenhouse gas emission, right? So, of course, a lot of things we have to do, but the energy sector is the main one. Now, if you look at global energy sector's emission, it's mostly by the coal, oil, right? Coal and oil, and by some gas. Then, if you look at sectoral, other sectors, must be the power sector. This one is a power sector, right? Power sector. That's why the power sector, even within energy, the power sector is very, very important driver of emission. Now, but the question is that, okay, energy is a major driver. CO2 emission from energy is a major driver, but amount of the emission space we have to emit in the future to be within 1.5 degrees of warming, which is an aspiration of the Paris Agreement under UN Framework Convention on Climate Change, that space is very limited. See, historically, we have emitted so much CO2 emission. Historically, we have a measure from 1850. You can see that the CO2 emission from land use has more or less stable, but CO2 emissions from the coal, we started industrial revolution. We use it slowly. We tap oil, then we started using oil, and now then we tap gas. We started using gas, right? Then now we are at a stage that if we want to stay under 1.5 degrees of the warming, amount of the CO2 left us to spend in the future is very limited. It's hardly 500 billion tons of CO2 emission left. We can only emit our remaining budget is 500 billion tons of CO2. And just imagine, even right now, we are doing over 40. It will run out very soon. So even from these conservative estimates, by the early 2030, we'll finish all our remaining carbon budget to stay within 1.5 degree warming. So that is a major challenge, which means that we are not in track to meet 1.5 degree of warming aspirations of Paris Agreement. We need to do more. We need to be more ambitious. we have to scale up our nationally determined contribution NDCs. We have to move rapidly to the renewable energy system. We need a rapid energy transition, right? That is fundamental requirement if we want to meet climate change. Okay, if we said, okay, we don't care climate change, science has shown that cost of inaction is much, much higher than cost of action. Future generation will suffer, and that for the human society, cost of inaction is much, much higher than the cost of action, right? So it's a kind of serious balancing to do. Now, if we really want to stay under 1.5 degree, this is a widely used figure coming out from our IPCC report. That means if we want to stay under 1.5 degree of warming, right, then whatever emission we have in 2019, we have to reduce CO2 emission by 48%. Whatever CO2 emission we have in 2019, by 2030, we must reduce to 48%, and we must reduce by 99% by 2050. That means we have to be carbon neutral. We have to be, we have to remove all CO2. We can't use CO2, right? By 2050, if we want to stay under 1.5 degree warming, 2050 is too far. Sometimes politicians are very smart. They say, oh, we'll do it for 2050 because their election will be finished in, for the politicians have a 4-year election cycle, right? But they have to deliver something for 2030. They are serious for 2030. When you say do something for 2030, they think seriously perhaps, right? For 2030, they should be able to reduce emission by 48% to stay under 1.5 degree of warming. So that is the challenge. And that challenge is what the challenge for the energy sector, because energy sector has to decarbonize. Energy sector decarbonize means you have to massively and rapidly move to the renewable energy system, right? So that challenge is what the challenge of energy transition. So everybody is talking about energy transition. Yeah. So fortunately, name of your degree program is energy transition in AIT, right? Sustainable energy transition, right name of the program. Okay, so also this figure is something very important I want to share with you. Our committed carbon is very high. When I say committed carbon, what is the meaning of committed carbon? Committed carbon means the carbon which is already locked in the system, which is very difficult to release. That means these are the CO2 emissions which is already locked in. The way we have developed our infrastructure, it's very difficult to avoid in the future, already logged in. Well, what it means, we have a coal-fired power plants, right? And we don't retire coal-fired power plants. Coal-fired power plants have a 30, 40 years life if they keep on running. We are already committed to that particular one, right? So this is a very interesting figure come out from our chapter in IPCC. Also, it says that a large amount of the carbon is already committed because we have already built coal-fired power plants, and we are planning to build more coal and the oil and the natural gas-fired power plants. Already we have planned. That means we have already locked in our system for that amount of emission. And I told you that the emission space needed is only, emission space we have is only 500 billion ton of CO2 to stay under 1.5 degree. And if you look at here, our already committed fossil fuel is already hitting that number, right? Already hitting that number, right? So for example, what I meant is that if unabated emission from currently planned infrastructure in the power sector is included, they would amount 850 billion ton of CO2, right? So if our existing and the planned fossil fuel infrastructure, if they keep on running without retiring them early, then all our remaining emission budget used up much earlier, right? So which means that we have to think about retiring our coal-fired power plants, right? This is one of the mechanisms discussed for Indonesia and a couple of countries, right? So when we were in ADB is trying to find a mechanism to buy back power plants or do something to retire some of the coal-fired power plants in Indonesia, right? So that this so-called legacy emission, or we call it, locked-in emission or committed carbon, we use a different word, that could be avoided in the future, right? Otherwise, even though whatever solar we add, this power plant keep on running, is not going to do good. We have to find a way to retire these power plants, right? Early than their lifetime, normal lifetime. So that is, otherwise, we have lots of emission already locked in into our system. If we really don't change infrastructure, if we don't retire this infrastructure, that is the problem. Now, I want to say a few words, and these are largely coming from IPCC energy chapter, right? I just pick as it is because they are very useful and they provide high-level summary coming out from the energy chapter of IPCC Working Group 3. It says that energy demand and energy sector emissions have continued to rise. Of course, we know that, right? Energy is a major driver. They have continued to rise. Fine. The warming cannot be limited to well below 2 degrees Celsius without rapid and deep reductions in energy systems carbon dioxide in zero, which is very obvious. We already said that we have emissions which is limited. We have, if we don't do massive energy transition, it can be met, right? And of course, it says that it requires to reduce fuel consumption, fossil fuel consumption, increase production from low and zero carbon energy sources like a solar and others, and also increased use of electricity and the alternative energy carriers in next 30 years. So I think, anyway, we have met that point. Now, then IPCC try to visualize net zero energy systems, right? What would be the different components of that net zero emission system, net zero energy system in the future? They will share some common characteristics, but of course, every country is different, right? Every country is different, so there will be adaptation. But some of the common elements is that electricity system that produce no net or CO2 removal from the atmosphere. That is needed, must. They have to be CO2 neutral, right? They can do a lot of things, but CO2 neutral. That is needed for net zero emission system. And also, lot of widespread electrification of end users, including light duty transport, space heating, and cooking. So all this sector need to be electrified, and that electricity should come from renewable energy, right? In our net zero energy system. And substantially lower the use of fossil fuel than today, right? Then, of course, that net zero emission system can also use some carbon capture and storage, CCS. If we cannot make zero, we cannot fully move to the renewable energy, then something can run, but we have to remove the CO2, right? That's why use of CO2 removal is very, very important. Either direct air capture or using BECCS, bioenergy with carbon capture and CCS, or some other kind of offset mechanism to really suck CO2 from the atmosphere. Otherwise we can't meet that, right? We have to do that, and we have to be more energy efficient. We have to reduce our energy demand. We have to have, as you mentioned earlier, energy system integration across region, energy system integration for renewable energy, storage systems, hydrogen, bioenergy, ammonia, and lots of things need to be integrated into that zero energy system. So it has to be a diverse set of things for approaching towards net zero energy system, right? Now, we know that the price of some of the renewable energy has declined. For example, solar PV, wind, the batteries, the price has dramatically come down, which is good news. But how to scale that up? How to bring that into the system much quicker, much faster in large scale? That we have to think. And of course, not only price, as I said, increasing the their implementation. We have to do a divestment. Divestment means we have to take out money from the oil and gas sector and invest more on the renewable energy sector, right? A lot of investment need to be channelized in order to make that happen, right? And also we already said we have to address the stranded assets. This lock-in, what I said earlier, committed carbon. A lot of this stranded assets, existing coal power plants, existing industry working on a coal. These are stranded assets, right? So this committed carbon, locked in carbon, we have to be able to address. Otherwise, if this infrastructure keep on running, then it's very difficult to meet 1.5 degree, right? Then of course we have to this new energy system, renewable energy system, need to produce a lot of opportunities like a job, many other opportunities, right? So then every region would be different, right? Then every region has to optimize themselves in what works in this region, right? So just to show what I mean by technology. If you look at here, photovoltaics, this is a cost, LCOE, levelized cost of electricity. The cost has just look at from 2000 to 2020, by how many times the price has fallen. Solar PV. Look for onshore wind, offshore wind, concentrating solar power, CSP, and for a battery for electric passenger, see how the battery price has declined. Just in a decade and a half, the battery price, and it's continued to fall. We have lots of progress. Again, a lot of adoption. For solar photovoltaics, its implementation, total installed capacity is really going up. Same for the onshore and offshore wind and CSP, and especially for electric vehicles, right? So battery. So now this technological improvement have provided some greater hope, but as you earlier mentioned that we have to be able to integrate that into our system. That integration is must. So this in IPCC also talks about the electricity system powered by the renewable will be increasingly viable in coming decades, but it will be challenging to supply entire energy of the renewable energy. I think some of you are already saying, which means that we have to have multiple energy systems into the place. Nuclear energy and hydropower, we can make use of it. Solar PV are now cheaper. We have to, but that is location specific. Bioenergy at the moment accounts for about 10% of the global primary energy. How to scale that up? Carbon capture is important because still we cannot make our all energy system zero. Still some fossil fuel will be running in the system. So we need to have carbon capture, widely need to be used in the oil and gas sector. Maybe that still need to run. Actually, if we can use carbon capture and storage with a biofuel, we have a double benefit. Biofuel themselves as a carbon neutral. And if we can capture CO2, that is actually enhancing the sink, right? So that means if we don't widely adopt many of these things, then it's not possible otherwise, which means our challenge is pretty big. Challenge is pretty big, right? So, and also I want to share you this figure particularly. We did this assessment. We did the assessment where we try to see how much are the potential to reduce emission by different options, demand side options. You said if you see the energy, there's a huge potential to reduce by wind energy, solar, hydroelectricity. You see that these technologies are not a rocket science. They are already proven technology, and their price is going to decline in the future, right? Their technology is going to improve in the future. So still they are sometimes expensive, but we have lots of potential from this technology. But again, technology alone is never enough, right? Okay, so that is about low carbon energy system or decarbonize. Let me say a few words about the renewable energy, because renewable energy, I want to put some focus because there are a lot of questions about renewable energy, right? Now, at the moment, renewable energy contributes globally only 12.6%. 12.6% of the global energy consumption is renewable energy. Now, in the electricity sector, renewable energy, it could be different, but in solar and wind, reach 10% of the global electricity generation already. Now, of course, there's a lot of change over the years, and particularly for the electricity generation, share of the renewable energy is higher. About 28% is the renewable share in total electricity generation, and that share is increasing, right? But the overall remains 12.66%. Now, why renewable is important? Because it is linked with the reduction in greenhouse gas emission. It can reduce air pollution. It can help us improve energy access, because renewable energy is much more distributed than coal or oil. Some place has wind, some place has biomass, some place has solar. So it's more distributed. So it can help us to improve energy access, right? Because energy access can be, now the technology price is coming down. So it really helps a lot. It helps promoting energy security, because many of these sources are available in many countries. It really helps the energy security. And also especially distributed and off-grid application. These are very nice, and it helps us avoid long infrastructure, expensive infrastructure, and these renewable energy systems, if we can use, help us avoid costly infrastructure reliance, and also it can create job and contribute to the livelihood in the local communities. But now, there are many studies, how renewable energy will play a role in the future under different scenario. So I'll not get into too much, but what I want to say that renewable energy and the fuel switching, energy efficiency, they are a very, very fundamental part of any of this discussion about climate change mitigation or energy security. Whether you look at this DNV Energy Transition Outlook, or if you look at International Energy Agency's different scenario. So these are, energy sector is a major part, and the transition needed where energy efficiency, hydrogen, biomass, wind, solar, a little bit carbon capture and storage, all these should be the part of the future energy system. And these are important part for energy transition. Now, if you really look at some of the scenario, you'll be surprised to see that in terms of capacity expansion, now the renewable energy is actually, the capacity expansion of renewable energy is much higher than the non-renewable energy in power sector. If you look at 2021, 315 gigawatt of the renewable power capacity has been added, and compared to others, it's much higher. The solar, this one is total 315 gigawatt. I think if you add, and under any scenario, you can see that the role of the solar, wind, and other form of renewable energy is really going to increase in the future. So many scenarios says that it need to do triple. If you want to have a net zero scenario, renewable power addition must triple, and that's where lots of efforts we see globally. Then, of course, the renewable energy alleviates energy market instability because it's more reliant on the domestic source, and also it helps us some of the large-scale technical failures, because renewable energy can be also worked, isolation is possible in the grid system, and so many other things, and also physical security, because very diverse source. as diversity is better, I think the security would be better. So, and also renewable energy already creating a lot of jobs. International Renewable Energy Agency, IRENA, estimate show that in 2001, as you can see, there is 12.7 million jobs created by the renewable energy. And now more and more, of course, as you can see, solar, bioenergy, and hydropower, they are three areas they have created lots of jobs, because job creation is very important, right? Job creation. So, and that trend is increasing. Let's say in 2012, 7.3 million people were in this business. Now 2021, it has increased to 12.7 million. So job creation also is being happening, and that also the added social value for this renewable energy. Now globally, we have hydropower about 1,197 gigawatt globally, hydropower. Yeah, recent additions are relatively less, but still something is being added. If you look at solar PV, by 2021, we have total cumulative installed capacity of around 942 gigawatt globally. And in 2021 alone, there was 179 gigawatts added. As you can see that all this capacity installment is very, very high of renewable energy. CSP, concentrated solar, is slowing, but still significant. Solar thermal heating and cooling is rising, and the wind installed capacity are still very good. In 2021 alone, 102 gigawatt wind was installed, mostly in China, US, Brazil, Vietnam, UK, these countries. So we are seeing the trend, and also distributed renewable energy help us to improve energy access, right? Distributors one, around 7.43 million off-grid solar lighting products were sold in 2021, and that number is increasing. Now the renewable energy-based mini-grid technology also fast growing. And also, of course, we are not in track to achieve the target for universal access to clean cooking, but that one area is still we have to work with. I think we are doing very good in electricity access, but we are not doing that great in cooking, clean cooking, right? So there are also distributed RE can play more important role. So basically, share is rising for renewable energy, 12.6% in 2020 now, but now power sector already high, around 28%. Hopefully we can push that further. Solar, thermal, and biofuels, they are rebounding. Investment is rising, around $366 billion investment in renewable power in 2021. But of course, they are still less, right? If you compare with the subsidy, this was estimated sometimes back. It was in the global status report. Compared to $5.9 trillion, anyway, investment is still low. Again, the subsidy estimations, they are different, done by different agencies. But divestment is continuing. That means investors are investing more and more on renewable energy. Investment is going to the direction, which is good news. And the climate finance, there's a lot of money flowing in for the climate change, climate finance. And that a major portion has gone to renewable. See, 57% of the entire climate change mitigation finance have gone to renewable energy in 2019-20. I'll try to show some figure. So there is a lot of transition happening. One can argue that this is not enough. Whatever we are doing is not enough, but a lot of transition happening because the price and the market is propelling renewable energy such as solar, wind. Technology has improved, cost has come down. And you can look at this slide. This is the latest one from IRENA. I think this is our installed capacity these are the annual, what is this one? Total cost. Cost has declined, capacity factor has improved, and the price has declined. These are all good news to really scale up the different technologies like a bioenergy, concentrating solar power, geothermal, hydropower, offshore and onshore wind, and solar photovoltaics. But particularly look at solar photovoltaics. It's with quite a phenomenon, right? Yellow line is quite a phenomenon. That's why it's catching a lot of attention. And also, good news is that countries are realizing need to move to renewable energy system. And actually, there are a lot of countries where they have put incentive system for renewable energy. 156 countries they have provided some kind of regulatory incentives or mandates. 70 countries they have in transport. 26 countries they have provided very strong policy in heating and cooling sector. But in power sector, 156 countries they have very strong policies for renewable energy. So we are moving to the direction, perhaps the right direction, but maybe we still need to move faster. And also, many countries have a target on renewable energy. 118 countries, they have a economy-wide targets for renewable energy, that how much percent they want to reach, right? But 135 countries, they have a target typically for the power sector. So people are quite serious in putting target. Thailand has a very clear target. Thailand's renewable energy plan, power development plan, they have a very clear target, how much percent they want to reach by 2037 for Thailand. So, and that target, the country's initiatives are going forward. Right? Then nationally determined contributions, which is a Paris Agreement document every country submits. There, the role of renewable energy is quite upfront. Renewable energy is a key area where commitments are made under nationally determined contributions for Paris Agreement and others. Things like carbon pricing, policies banning or phasing out of the fossil fuel, try to ban the fossil fuel for road transport, funding for international fossil fuel project banning. So lots of things exist in those targets. But again, we can always ask whether that is enough, right? So in their net zero policies, lots of things are happening in the countries around the world. You can always explore more. But I'll end my discussion in next 10 minutes with few slides on carbon financing, climate financing, which is very important. The reason I'm bringing these slides because there is so much money flowing in the name of climate change, and that money is actually going to the renewable energy system and energy system globally. This is the latest data available. Climate finance, the average of 2019-20, we have roughly $650 billion globally flowing for climate finance, out of which, as you can see, the majority of this money is going to mitigation, climate change mitigation, and adaptation. Very small, peanuts money is going to adaptation, right? Mostly going to mitigation. And as you can see, the big money going to energy system. So out of the $653 billion US climate finance, more than 50% is going to energy system. And this $336 billion money is an important source to move us to renewable energy system, to improve energy efficiency, all kind of things. That's a very good money. And that number is going to increase in the future. This is what we could track. And now, if you really look at IPCC, IRENA, IEA documents, they say that this is not enough, right? See, in last slide we could track. Oops, sorry. What happened? Okay, in this slide, we could track $336 billion climate financing going to energy system right now. But that is not enough. There are a lot of scenarios telling us that we need, like let's say, International Energy Agency's net zero emission scenario says that we need $1.2 trillion per year investment in energy system. At the moment, the revised estimates is around 350, let's say 350 billion, but we have to scale this up to 1.1 or $1.2 trillion to meet 1.5. So, which means that a lot of money will come to the system if countries are serious, right? So that's why, I was mentioning you earlier that even the bank like ADB, trying to convert itself into the climate bank and major funding portfolio to be given to the climate change. And similarly, that money can from many sources, and it's not only from multilateral banks. If you look at the earlier slide, see the money comes from so many different ways. Money comes from governments, it comes from national domestic financial institutions, it comes from bilateral institutions, it can come from multilateral financial institutions, it can come from climate funds, it can come from state-owned enterprises, it can come from state-owned financial institutions, and commercial, from balance sheet, household, individual. There are so many different sources for money. We have not been able to channelize institutional investors like a pension fund and other big institutional investors. If they come into the picture, money is still not a problem, but how to make it happen is a problem. Now, I just look at this figure that this is how much money invested. The recovery from COVID-19 pandemic. Now there is some boost in the energy investment. This is the amount of investment that has gone to fossil fuel, and this is a clean energy. You see that investors are actually investing more on renewable energy already. So amount of the money that has gone to fossil fuel is now less than the clean energy. And the clean energy investment in 2023 has hit $1.7 trillion. So that trend is a good trend. But of course, these numbers needed is much bigger and different way. Measurement are different sometimes, but again, we need more. That's not enough. But where this investment is happening, if you see that electric vehicles is an interesting area. See, we have no investment in electric vehicles till 2018. See, look at this yellow bar in this figure. It has grown from a very, very tiny yellow bar here in 2018 to a big chunk in 2023. The electric vehicles, there's a lot of investment in electric vehicles, battery storage, some of the major things are happening. So what we said is that there's a limit, we have to limit fossil fuel use, and we have to chart low carbon pathways, how to move to low carbon pathways, decarbonized or net zero emission based energy system. This is where we need to go. Now, renewable energy technology innovation has happened. A lot of improvements have happened. You saw in solar, wind, price came down, efficiency increased, more investments are happening in the RE sector, more and more, install capacities are being built. It's happening, but still how to scale up, how to integrate. Integration is key. Unless battery storage and some other supporting technology still doesn't become too apparently viable, still it's difficult to fully rely on the full renewable energy system, right? So still we have to that's why system integration is very key. And policies are key. There are lots of policies already, right? Whether we call it renewable energy targets, mandates, feed-in tariff, competitive tenders and auctions, net metering, financial or fiscal measures such as taxes or subsidy, renewable portfolio standards, rooftop solar PV mandates, ban on fossil fuel heating, renewable heating and cooling standards, building code, electrification, biofuel targets. There are so many policies, right? And countries are doing. Of course, one thing is not needed. We have to have all these policies, right? The reason I'm saying is that one solution is not enough. We have to do a multiple thing. And from my perspective also, system integration is very important. System integration is very fundamental. If we do not pay enough attention for system integration and we just keep on talking solar, it's not going to do better. System integration, integration for grids and storage, this is going to be crucial if we really truly want to move in the future. And of course, making policies easy, but implementing policies is what matters, right? And also one area we have not still paid enough attention is clean cooking sector. We have done remarkable progress on access to electricity, but our progress on clean cooking sector is still very, very weak. This is one area very much important, needed in all energy sustainability debate. And of course, upscaling EVs and cleaner transport is needed, right? But electricity should come from renewable. If we scale up electric vehicles, but still rely on the coal-fired power plants, it doesn't going to do any good. We have to scale up EVs, and the electricity need to be progressively renewable. Then we have to eliminate fossil fuel subsidy. Fossil fuel subsidies are distorting the market, and it is killing the level playing field for renewable energy. We have to address this big elephant in the room, fossil fuel subsidy. They must be eliminated. And also, of course, making use of climate finance. I already showed you some number. Energy sector can be a big beneficiary of the climate financing. The whole world is moving. So how to facilitate, how to do investment facilitation, how to do divestment, these are fundamental. And of course, in order to chart all pathways, we need evidence-based with a science-based approach, especially in developing country. Planning cannot be on the whim of the politicians, right? Cannot be, should not be. And we know policymakers, politicians always don't listen. We know. Let's not be very ideal. In any country, cost-based policies from the viewpoint of expert might never happen. But still, science-based approach, evidence-based approach is needed to guide the policy and choose right thing from a set of policies. At least science researchers like us can show the pathways which should be pursued and which should not be pursued, right? If the policymakers choose pathways or policy from the forward-looking, evidence-based ones, that is still, I think, the good thing to do. So I think that is our role, and I think these issues are big issues. I think we all can reflect upon. The issue has been raised sometimes that, okay, if we rely on a lot of battery, particularly electric vehicle, then the battery need to be managed, the waste from managed. But we have to deal with that. I think we have no choice. But my feeling is that these are not the mobile source pollution like a tailpipe emission from the vehicle. So we could develop a system where this could be efficiently collected and dealt with. For example, in one of my previous class, Nima was there, we are talking about things like extended producer's responsibility. And we are talking about circular economy. We're talking about so many different things. We could easily create a system of like an extended producer's responsibility. That means the car manufacturers have to manage the battery, right? There are many systems that are there, so-called extended producer's responsibility. And there are recycle mandates. They have many different policies. But what I think is that since they are not the mobile source of pollution, unlike the motor vehicles, that they can be managed. But of course, there could be also a lot of discussion going. I have seen in articles, for example, maybe the electric vehicles need high quality battery, but the battery used in electric vehicles, after they finish their job, they can be used in other applications. So that means, again, reuse, extend life. There could be a lot of things we need to do, but definitely that is a concern. And the solar PV, but solar PV life is still reasonably good, but that waste planning, waste management, other things, it's better to start thinking that, particularly the battery. It's something that I think we have to also start thinking well early in time before there will be an explosion of electric vehicles in the market. Actually, some economy already going on. Actually, I was in Kathmandu last 2-3 months back. There is so many electric vehicles in the cut from the street now. And I think maybe it's very cheap to operate because oil is very expensive. Electricity is unimaginably cheaper. I think geopolitics is unavoidable. For example, when the battery technology will evolve, maybe the lithium, who provided lithium, who provide nickel. This country will be new kind of new kind of oil field kind of equivalence. For example, Indonesia has a huge nickel reserves. Actually, one of the country with the largest nickel exporter and all. So Indonesia itself was trying to be a kind of battery hub globally. Something they have some kind of ambition. But you are right that at the moment maybe we don't think too much. But as more and more electric vehicles, battery comes to the market, then who controls the technology and who provides the material, especially whether it needs some precious raw materials, mineral earths, or things like lithium, nickel, these countries will be playing major role. And not only that, maybe lots of country with a strong wind technology, for example, efficient wind technology, efficient solar technology. So I think that is unavoidable. Maybe a new kind of things might emerge at the moment. For example, let's say the Middle East is very important for the oil, right? So maybe stability in the Middle East is very important. Maybe in that case, those countries who provide the material, things like lithium or nickel, maybe this country will be more important. So I think that is unavoidable. But still we have to see how things emerge. Actually, personally speaking, I haven't really looked at the resource side of this battery. What kind of global resources exist. But what I know is that some people are now talking about this kind of material balance or the material reliance, especially for nickel, lithium, and a couple of other important aspects which is needed for the battery and other technologies. Now, decarbonization basically is a broader term, which means that we have to decarbonize our system. Decarbonize, let's say in case of energy system, when you say decarbonize energy system, it could mean many things. So basically the decarbonized energy system basically means that improving energy efficiency and also switching to the fuel sources which actually do not emit CO2 emission, or using the technologies such as CCS, carbon capture and storage, or something from the energy system. So broadly, those are major things that we use the word decarbonization. But sometimes it can be also used for things like using it for the bioenergy, sequestering, from bioenergy to CCS. So basically, it's a try to avoid CO2 emission from the energy system. So that word we use, decarbonization, moving away from CO2 emissions in the energy sector. That's a decarbonization. Due to the energy crisis, Ukraine war, energy prices rising, then putting carbon tax is difficult. Even government has to increase subsidy in fossil fuel, which they want to remove themselves. So all these crisis is creating definitely lots of problems. Climate financing happens with so many different channels. In my slide, you have kind of spaghetti kind of chart, right? Many different way, which is very difficult to track. I don't know whether we have been fully able to track. That one shows numbers 635 billion or something. But even the private financing side is very difficult to track. But there are a lot of initiatives which are trying to track climate finance. But the international public financing is very easy to track. For example, under the UNFCCC, they have tracked around $80 billion. $80 billion because the developed countries committed developing countries that they will give $100 billion, right, by 2020. Now the different agencies are tracking that commitment has not been met. I think they have come around 80 billion they could track. The ODI does some tracking. They have some agencies which do the tracking, but still my sense is that the tracking the private money is very difficult. Public money we could easily track, but the private sector, and also see climate change is such a fuzzy word in a way. What is climate change? What is climate finance? What is not climate finance? That definition itself is very carefully need to be done. Let's say somebody fund for bus for the public transport. We can tag that as a climate fund, right? So, but how to do a climate fund, that is the issue. And also a lot of discussion these days about green bonds, climate bonds. A lot of bonds being issued in the name of climate bonds, and that area can bring a huge money from the bond market. Now the people are quite serious. ADB started Asian Bond Monitor, a new actually platform to really monitor and provide guidance on the bond market. Is something that not yet been tapped. But finance is kind of complicated there. I don't think we have many people working on climate finance here in AIT. I do small work, bit more synthetic work on climate finance here and there, but not really expert as such. But we really don't have much expertise on climate, basically this financial management side. School of Management guys, they have something, but still their angle is very different. So it depends, right? That money doesn't go to the central fund of the world, right? So some country impose carbon tax because say carbon tax is a way to achieve their climate targets, right? For example, Sweden is a country, perhaps the world's highest carbon tax, $150, $160 per ton of carbon, Sweden, right? So again, see, every country decides how to do it, right? Some use carbon tax in certain sector. Some use cap and trade kind of emission trading mechanism. Some use some legislation or some other way. Some use the market-based incentives. So every country use it differently. Now, at least in our part of the world, so far, only 2 countries have doing the carbon tax in Southeast Asia and South Asia. For example, Indonesia. Indonesia started 5 Singapore dollar per ton of carbon since the January 1st, 2019. Singapore started. Now the Indonesia was supposed to start last year. They pushed this year. Hopefully they will do it. But only $2 per ton of carbon tax. Some others are thinking carbon trading. For example, Thailand started a voluntary carbon market, experimented voluntary carbon market or something. But the pricing carbon is needed, but still countries are hesitant to put a price in carbon still. Oh, there are many policies, right? So as I said that, there are so many policies, right? Depending on sectors. But my feeling is that if we can have economy-wide policy instruments, that would work more holistically. For example, carbon price. Now, putting a carbon price on everything, that way affect the entire sector, right? Rather than doing here and there. So if the energy system is not decarbonized, then if you use the electricity, then definitely we are not doing the right thing. So we have to use electric vehicles, then charge electricity, and that electricity should come from more and more renewable energy, right? That's a prerequisite. Now, how to do that? Of course, different power companies have different way of doing it, right? So for example, they can show that certain percentage of their electricity has come from renewable energy. They have renewable energy obligations and other kind of policy instruments which can play into. Government can say that, let's say in Thailand, can say that, okay, PA, Provincial Electricity Authority, whatever electricity you sell, 30% it should come from renewable. Sometimes if government impose, then the PA has to buy renewable energy sources. So ultimately, it's a total energy mix, right? So some companies say that, yeah, we provide green electricity. Consumers are aware, they are ready to pay a little bit more higher price for that electricity. Or if some companies say that, then the company need to demonstrate that they buy electricity from the renewable energy, right? So something that they have demonstrated. So I don't think that is too difficult, to monitor, but depending on how seriously we do it.